Hello, welcome to my session talking about hybrid data lake on Google Cloud with Alluxio and Cloud Dataproc. My name is Roderick. I'm an engineer and product manager for Dataproc at Google Cloud. So today, many enterprises originally thought that data lake is just a storage. The data lake comes with new capabilities such as analytics and machine learning at low cost because it runs on commodity hardware. This leads to companies to have aspirations of self-service analytics on large volume data. So then companies spend a lot of time and money on setting up data lakes over the years. But now they realize that traditional data lakes don't always meet the expectation delivered value. Many organizations struggle to realize the original expected value, and it fails to get critical business insight out of their data. So they're facing many challenges. So this includes, total cost of ownership. Containing the cost at scale it's a big task in itself. Companies currently uses less than 1% of unstructured data. According to IDC, by 2025, 80% of the world's data will be unstructured, which means that if these things are still the same, it'll be even more costly to store data and get even less value out of these data. And there's scaling challenge. Hadoop was originally to design to be scalable, but there are other unexpected that come out of this. Clusters are running beyond 100% capacity, and data and compute are co-located, so it's hard to break them up. Workloads will compete for resources, and expanding the cluster will be difficult because the high load to the HDFS master nodes. There's data governance challenge. There are data silos in there, so it's hard to find a single ownership that governs all the data. The value and possible advantage are not clearly defined, and it's hard to be justified for budgeting. And out of that hinges the ability for the self-service analytic platform to be developed. There's corporate IT putting guardrails and red tapes here and there. So overall, the innovation is hampered. So many challenges here, but meanwhile, data lake is very important for enterprises because many of the ML, AI, and analytics reporting is depending on it. So it is evolving and moving to the cloud. So one of these clouds is Google Cloud. We have a portfolio of products ranging from managed open source to externalized version of our core technology as a service. In some cases, open source tool even derived from Google's core technologies through web papers over the years. So MapReduce is one of these examples. These products covers are pretty much at every stage, from data ingestion, storage, analytics, all the way to data activation being consumption. All of them put together build a data lake solution. Although this is our cloud vision, we do understand that clouds need to meet the organization and the users where they are today, which is why we partnered with Alluxio to provide a hybrid solution. Let me first introduce the directions of Dataproc, the core processing framework. So Cloud Dataproc is a managed Hadoop and Spark solution. So we run native Hadoop and Spark and other open source tools. There's no need to re-architect the application and code. It provides the ability to customize hardware and software to support various types of compute needs. Features include auto-scaling and flexibility modes. And it also enables separating storage compute. So the data will be stored on Google Cloud Storage, which is our object store. But we also provide an HDFS for temp files and caching purposes. Also, because Dataproc takes about 90 seconds to start a cluster, it provides agility, so generated advocates for using the ephemeral cluster for jobs. So this enables more flexible usage pattern and potential saving costs. In essence, Dataproc provides customer the great value for being fast, easy, and cost-effective for running open source software. But we're not just stopping here we're not just a yarn cluster for hosting different open source software. We're looking further into the future of the analytics world. We look at the open source community and the trends of the compute side. Then we saw Kubernetes as the answer. but it wasn't an overnight thing. So today, Dataproc, you can run Spark on Kubernetes cluster with the help of our open source, the Spark operator. This allows you to manage your dependencies better using the customized Docker image to run Spark. Kubernetes allows you to better utilize your infrastructure. And all this enables you not rely on Yarn and other Hadoop components. We'll continue to add more open source Kubernetes operators into our community, just like we did September last year. We open sourced the Flink operator for the streaming analytics. So what does it mean for Google Cloud users and ecosystem partners that build integrate with Dataproc? We'll have multi-cloud support, hybrid cloud support, better isolation, supports for more components, and faster deployment and easier management. As we containerize more open source project and partner components, more type of data analytics process can run on top of Kubernetes. So we'll offer our customer value by providing management and support. So that is the future. If you have on-premise cluster today, how do you get there? How do you leverage this advantage provided by the cloud? So here's your options, right? A traditional approach would be lift and shift. So you typically would pick a workload and move to the cloud together with all the data. So this typically, our data shows that it runs 30% cheaper in the cloud than running the same cluster on-premise. So you can decouple the storage and compute. So we'll move the HDFS data to Google Cloud Storage. There's no need to rebuild from scratch, right? Many of the components can just be moved over and it just works fine. But the downside is you need time to plan and move the data, and there's a hybrid stage, so it's hard to figure out which part of the data to copy, or how do I deal with incremental data? I want to keep them in sync. So all these are pretty big challenges. The other approach on the far right side is modernize. So we fully utilize managed services, decouple the storage and compute, and get access to fully managed and powerful non-Hadoop options, just like BigQuery, for example. It is a change for some it's a change for any size of organization, but for non-digital native organization especially, this is a big challenge. This is a big step towards the far right side. And here you have the zero copy bursting kind of scenario where you meet where the companies are today. There's no need to migrate data. So you don't need to figure out where the workloads and data is and move them accordingly before you can do some development. It provides a great compute and storage agility. So that's what we're going to talk about today. So how are you going to leverage Dataproc and Alluxio to do this? So why would deploy hybrid cloud solution? What does it solve? Customers want to keep investments and expand the cloud presence, right? Some of the customers say on-premise is enough for now, but we want to leverage cloud for additional compute power. You don't want to keep expanding our on-prem or don't know how to capacity plan or just don't have enough flexibility in the on-prem environment. There are some other customers, they're in the process of migration. Sometimes it's a long process, right? You need to figure out, just like we discussed, you need to figure out what part of data and application to move. Sometimes you need to replicate the data between. Just planning and figuring out this dependency of different application components and data is really, really difficult. So here's the Alluxio and the Dataproc joined together. So we have this zero copy hybrid cloud bursting architecture. So on the bottom, you see these are on-premise Hadoop clusters with HDFS as a storage, have your traditional component like Hive as your data warehouse. All of your existing pipeline are running here, and they're continuing feeding data into HDFS. On the top are Dataproc clusters. This is our burst demands are. and we create Dataproc cluster with Presto and Alluxio. So Alluxio metadata and catalog will connect to the on-premise HDFS and Hive. So we have, in between, we have interconnected internet. So any updates on the bottom on the HDFS cluster will be picked up by Alluxio. And the Alluxio, by the way, lives in Dataproc. So you don't need to figure out how to keep them in sync. It automatically, Alluxio listens to HDFS name node notification. They are automatically in sync. When the setup is done, you can start immediately processing data through Spark and query data through Presto without even considering moving which part of the data over. I need to copy that data. Do I need to change catalog? Do I need to reflect that in my Hive meta store? You don't need to do any of that. You just automatically make things work. If you want to keep the data on GCP to speed up data process and query later, you can set policy to let Alluxio store the cached data on Google Cloud Storage. So you don't have to every time go back and copy the data to the GCP side. When you actually migrate to the cloud, there are many challenges. Alluxio can make the migration much easier. So just like we just iterated, data being copied and bring to the cloud in an on-demand fashion, there's no need to think about how to keep them in sync and which data set to be copied. If you're migrating GCP, your data pipeline does not change anything and can continue to run as is and the data being migrated over time. Alluxio's metadata service can store a very large amount of file information, so you can even federate multiple clusters and even in other clouds. Alluxio's catalog service can also help managing access to structured data. So you can connect to Hive meta store and make table span across multiple storage services, even in different clouds. Security is another challenge when moving on-premise big data system to the cloud. You often need to deal with different identity system, authorization system, authentication systems, and more. Alluxio allows you to continue to use the existing Hadoop security architecture to govern your system. It integrates with Kerberos and Ranger to support strong authentication authorization. Like on-prem Hadoop, you can also enable TLS and also provides access lock to satisfy requirements for data encryption and auditing. A leading retail chain customer uses Google Dataproc, Alluxio, and Presto for their data lake. On the side, BigQuery serves their ad hoc queries as data warehouse. This architecture, just like what we discussed earlier, Alluxio here can provide benefit like accelerating data processing and queries, migrations. It provides, and also like because the caching nature of Alluxio, it also improves query latency and fluctuation in performance. The customer is very happy with the solution. So how do we get started with Alluxio on Dataproc? It's very easy. Dataproc has a feature called Initialization Actions. These are pre-scripted scripts to enable specific open source components. So you can pretty much follow this tutorial to download the Initialization Actions through GitHub and get things started. So here are the resources. You can follow these two links and read about it, and even do your own code lab to try it out. Thank you.